Welcome to physics practical session. The aim of today's experiment is to determine the value of a known resistance R and the resistivity of the material of the wire W. And this is the circuit diagram of the setup. As you can see, on the left hand gap is standard resistor 4 ohm. On the right hand side of the meter bridge is wire W connected in series with unknown resistor R, and this J is a jockey, G is galvanometer, E is a source of electricity, a source of electric current, that is battery, 2 dry cells, and K is switch. And these are the apparatus that we are talking about. This one is 2 dry cells connected in series with this holder. It's a battery holder. And this one is a switch, a switch K. This is a 4 ohm resistor, standard resistor. This is a known resistor R. This one is a micrometer screw gauge that will be used to measure the diameter of wire W. This one is a crocodile clip, okay, and this one is a jockey. This one is galvanometer G, and all these are connecting wires. This is a meter bridge, as you can see, and this one is left hand gap, and this one is right hand gap. These are the terminals, okay. It's a length as usual, 1 meter or 100 centimeter. That's called a meter bridge. It's called a length of 1 meter. And this one is wire W. Okay. Now, according to the procedure in the question paper, we'll start performing experiment, but before that I want to show a table of result. We'll be recording our data in a table of result. This is a table of result, okay. Table of results. We'll be recording the length X of the wire. This length X of this wire, starting 15 centimeter, 30, 45, 60, 75. The last length, for X will be 90 centimeter. For each value of X, we'll be finding a balance point and recording the value of L here, and that's 100 minus L. This, and then we find a equivalent resistor in this column. I'll show you later how to calculate this one, equivalent resistor. Okay. Now, let us start performing our experiment according to procedure in a question paper. Okay. Let us now start connecting our circuit. This is a dry cell, so I'll connect using connecting wires. Okay. I'll use connecting wires to connect this. Okay. This is a key. I'll connect this one. Negative terminal to a switch K, as shown in the diagram. Negative terminal of a dry cell will be connected to a switch, and then the other side I'll connect positive terminal of a dry cell to one end of a meter bridge, as shown in the circuit there. So I'm now connecting to this side. Okay, I can use this terminal or this one, all the same. Okay, now I'll connect on the left hand gap. I'll connect standard 4 ohm resistor, this one. So using connecting wires, I'll connect this to this standard ohm resistor on the left hand gap of emitter bridge. I'm done with that one. That is 4 ohm resistor. Okay, standard resistor of 4 ohm on the left hand gap of emitter bridge as shown in the diagram. Okay, now I'm done. Let me move to galvanometer, that is G. So I'll connect negative terminal of a galvanometer okay, positive terminal of a galvanometer to a G. This is jockey, so I'm connecting now jockey. This is jockey. Okay, I can connect here or here. All these are positive terminals, so I'll choose this, the middle one, positive terminal of galvanometer. Okay, I'm done with that one. So now I'm connecting right hand gap. We are told to connect a non-resistor R in series with wire W. So let me start with a non-resistor R. Okay, now we're told to connect crocodile clip on this right hand gap of emitter bridge. On this right hand gap terminal, connect a crocodile clip, and then we'll connect the wire, this wire W, in series with a non-resistor R. Okay, this wire should start with wire length X, that is 15 centimeter according to the procedure. So start with length equals to 15 centimeter. Okay, I'll put a mark there so that I'll use a crocodile clip to connect this one, that's 15 centimeter of wire W. Okay, now I'll start taking readings. Okay, my circuit now is complete. Okay, it's almost complete. Sorry, let me complete this side. Okay, circuit is complete now. So let me start now taking readings. Okay, I'll start taking readings now. See, now I'll switch on the circuit, and then I'll start taking readings. Okay. Yeah, so 70. This is the first reading. Length, because it becomes 70 centimeter, that is L. So let me record that value in my table of result. L becomes 70. Okay, this one is 70 now. Now this one is 100 minus 70, that is 30. Equivalent resistor here, you use a meter bridge formula. That is to say, you can use meter bridge formula, that is according to this diagram here. You can see it is 4 over equivalent resistor. That is to say 4 over RE is equal to L over 100 minus L. So that's option number 1. Or you can use, you say or you can either say 4 over L equals to equivalent resistor over 100 minus L, sorry. So you can use either of this. It's a meter bridge equation or meter bridge formula. So making subject equivalent resistor from here, we can make subject equivalent resistor from this. That is to say, it's now RE times L equals match. You say L times RE equals to 100. This is equal to 4 times 100 minus L. So it's 400 minus L. So making subject equivalent resistor RE dividing by L. So we say therefore equivalent resistor is equal to 4 times 100 minus L over L. So for this case now, is now 400 minus 70. For this case now is equal to, okay, is 4 times 30 over 70. So it's now 120 divided by 70, you get 1.7. So this is 1.7 approximated to 1 decimal place, 1.7 ohm. So we'll be using this formula each time, okay, to get the value of equivalent resistor. Okay, so this formula will be constant for each value of this equivalent resistor. Okay, now let us move to the next experiment, that is when length now is 30. When length becomes 30, that is we measure 30 using a meter rule. Length now becomes 30. Okay, almost there. Then you put a mark. I'll fold it just to make a mark. So I'm using crocodile clip. I will connect there. Okay, that is exactly 30 centimeter. So I'll switch on circuit as usual, then start finding the balance point. Start finding the balance point. Okay, there. According to, okay, this is 59.5 centimeter. So let me record 59.5 centimeter. 59.5 centimeter. So 100 minus 59, that is 40.5, isn't it? Yes. 100 minus 59.5 is correct. So we'll find this one later, we'll fill that table later. So let's move now to the third experiment. That is when the length now is become 45 centimeter. Okay, let's measure now 45 centimeter. Okay, there, make a fold. Okay, using crocodile clip, I'll connect this one. Crocodile clip there. Okay, now let me switch on the circuit and then we'll proceed. Switching on the circuit. Now let's find the balance point. Okay, that is now, the length now is 54.5. L is 54.5 centimeter. So let's record that value, 54.5 centimeter. 54.5 centimeter. 54.5. When 100 minus 54, that is 54.5, you get 45.5. That is, okay, now let's move to the next experiment. That is fourth experiment, when length is now 60 centimeter. Now let's proceed in the length now 60 centimeter. Using a meter rule, let's measure 60 centimeter. Somewhere there. Okay, make a fold. 60, yes, exactly 60 centimeter. So using a crocodile clip, let me connect this one. Okay, crocodile clip. So the length is now, let's find now balance point when the length is 60. Okay, switch on the circuit as usual. Then start finding the balance point. Okay. Okay. Now length of L now is 48.5 centimeter. So now let's record the value of L, 48.5 centimeter. So 100 minus, that is 51.5 centimeter. Okay, now let's proceed with the next experiment. That is when length is 75, length of wire W is 75. So before that, let me make sure that this one is properly fixed here. There is a jockey, seems to be loose, so let me tight properly. Let me connect properly jockey. Okay, right now let's proceed with the length now is 75 centimeter. Using a meter rule, I'll measure 75 centimeter. Okay, exactly there, 75. Make a fold. Right now let me proceed. Using a crocodile clip, I'll connect this one. Okay, now let me connect the circuit as usual. Connect the circuit as usual. Switch it on. Start looking for the balance point. Yes, there. So now the length is now 44.5 centimeter. LO is 44.5. LO is 44.5 centimeter. 44.5. So 100 minus 44.5, that is 50. How much? So let's 100 minus 44.5. That's 55.5. 55.5. Okay, let's now move to the last experiment. That when X is now 90 centimeter. Now let's measure 90 centimeter when the length is 90 centimeter. So let me measure 90 centimeter. Almost there. Okay, almost here. So let me make a fold, and then using a crocodile clip, I'll connect this one using crocodile clip. Okay, yes, that is 90. When the length X is 90, let's connect, switch on the circuit by plugging. Okay, switch here, start looking for the balance point. Okay, alright, length is now 40.5. Okay, it's 40.5. Length is 40.5. LO is 40.5 centimeter. That's be the last 40.5 centimeter. 40.5. So this one is now 100 minus 40. That is 50. Is it 59.5? Okay, let me confirm. 100 minus 40.5. Yes, correct. So let's now fill this. Let's fill this part here, equivalent resistor. So in each case now, we'll be inserting the value in this formula. So is now 4 times. For that case is, for this case now, is 100 minus 40. So 4 times, that is 4 times 100 minus 40 is that, it means 40. Yes, that is 40.5 over 59.5. So 4 times 40.5 divided by 59.5, you get 2.7. 2.7. Okay, it's 2. 2.7. Okay, now let's move to this part here. That is 4 times 45 over 54.5. So 4 times 45.5 divided by 54.5, you get 3.3. Okay, now let's move to the next, that is this here. So it's 40 times 51.5 divided by 48.5. So 4 times 51.5 divided by 48.5, you get 4.2. 4.2. Okay. Okay. This one here now is 4 times 55.5 divided by 44.5. 4 times 55.5 divided by 44.5, you get 4.9, approximately 5 exactly. Okay, 5.0. Now let's move to the last experiment, that is let's fill this one, that is 4 times 59.5, okay, over 40.5. So 4 times 59.5 divided by 40.5, you get 5.9. 5.9. So that's, we are done with the filling of the table. I have already filled the table. Now let's go back to question paper, see what we are told to do. Okay, now we are told to plot a graph of RE against X, okay. That is D. You are told to plot a graph of equivalent resistor RE against X. So this one and this one. So RE is against X, this one. Right. Now let's plot a graph of equivalent resistor against X. Okay, now we have already plotted a graph of equivalent resistor against X. A graph of equivalent resistance against X, that is RE against X, this one here. As you can see, the graph is straight line with positive slope and intercept somewhere. Okay, now according to the question paper, we are told to, from the graph, that is now E, okay, E Roman 1, from the graph we are told to deduce the value of a known resistor. Deduce the value of a known resistance. that was R. So this one, from the graph you can see the intercept where the graph cuts here around 1 ohm. Okay, so from the graph R is equal to 1 ohm. So unknown, therefore we say unknown resistance R is equal to 1 ohm. Okay, this is the value of unknown resistor from the graph. We are done with that one. That was E Roman 1. Okay, now E Roman 2, the resistance per unit length of wire. The resistance per unit length of a wire. Okay, resistance per unit well, this one can be calculated from the slope. Okay, you know the slope is equal to change in RE over change in X. So change in equivalent resistance from the data here is 5.0 minus 2.7 over that is change in X, that is 75 minus 30. Okay, okay, now slope equal to 2.3 over 75 minus 30 is 45. So we get 2.3 divided by 45, you get 0.051. This one will be in centimeter. Sorry, this is ohm. Sorry, ohm. This one in centimeter. So if you check unit properly, you'll get something like ohm. This is, will be the slope. But the question says we need a resistance per unit length. Actually, this is the slope of our graph. Now you can change that one or into ohm per meter. You can say now that is if you multiply by 100, that is equal to 5.1. okay, or 5.1 ohm per meter. Okay, this is the value of an resistance. Therefore we say resistance per unit length of the wire is equal to 5.1 ohm per meter. Okay, done with that one. Okay, F, we are told to measure the diameter of the wire and hence find the resistivity of the wire. okay, while that is F. Okay, now let us measure the diameter. Measure the diameter. Okay, diameter D is equal to how much? Let us measure now using our micrometer screw gauge. The diameter of wire okay. Okay, the diameter is 0.36 millimeter. 36, okay. The diameter is 0.36 millimeter. That is diameter of wire. So this one you can change into meter by multiplying 0.36 times 10 power minus 3 into meter. So if you change that one, you get 3.26 times 10 power minus 4 meter. So that diameter of wire W. Okay, now we are told to calculate or to find the resistivity. Calculation for resistivity. For resistivity, okay, of wire W. Now, from the slope we have calculated there, and you know that equivalent resistor, okay, from this one, equivalent resistor R is equal to resistance of that wire X, okay, plus unknown resistor R. Okay, now this value here R, we know from the formula of resistivity, okay, R is equal to resistivity, okay, times length over area, okay, but this length here is X, okay, but L is equal to X, so instead of L we will be using X, okay, so we say RE is equal to, so instead of putting now R, we'll put this one here, so it will be resistivity times X over area, over area plus R, unknown resistor, okay. Okay, now from this equation now, this X here represents length, okay. This equation now, if you equate or relate with the equation of straight line, you get something like this. That is RE now, equivalent resistor is equal to resistivity X over area plus R. That was a known resistor. So if you write in the format, in the form of this one, if you write in this format or relate to this one, sorry, if related, with the equation of the form of this form, that is y is equal to mx plus c. So we get something like y now equal to mx plus c. So you see the whole, this one here is related to slope, and this one x is related to x. This one is intercept, unknown resistance intercept, and RE is y-axis. X-axis related to this one, length x. Okay. Now, from there now, we say resistivity over area is equal to slope. So, because we have now slope is equal to resistivity over area. Okay, but we have the value of slope. Okay, slope is equal to 5.1 ohm per meter. Okay, now we say 5.1 ohm per meter is equal to, so resistivity over area but area now is equal to pi d square over 4, which is equal to, you have diameter there, this one here, diameter. So if you insert here, you get 3.14 pi times 3.6 times 10 power minus 4, and then squared divided by 4. Right? If we insert that value, okay, 3.6, okay, raise minus 6 minus 4, and then squared, okay, times pi, that's 3.14, okay, divide by 4, so area is equal to 1.0, approximately 0.2 times 10 power minus 7, that is meter square. Okay, that's the area of that wire. Now, so 5.1 is equal to resistivity over 1.02 times 10 power minus 7. Okay, making subject now resistivity. So we say resistivity is equal to 5.1. This one, remember units, times 1.02 times 10 power minus 7. So unit for this one was ohm, that was ohm per meter, times area, that was meter square. Okay, so this one cancels this one, you remain with 1 here. Okay, we remain with ohm meter. So if you multiply that one times 5.1, get something like 5.19 times 10 power minus 7 ohm meter. Okay, this is the resistivity of the wire W. Okay, the value of resistivity, therefore we say, therefore resistivity is equal to 5.19 times 10 power minus 7 ohm meter. Okay, well, we are done with that one. Now we need to, this question says that mention any two sources of errors and precautions taken in this experiment. Okay, sources of errors. Need two sources, okay? Two of them. Okay, one. Okay, might be loose connection, or might be a loose connection of connecting wires. These precautions, how can you avoid that one? Precaution is to tighten and check regularly okay, so it's to tighten all the time and check regularly wires if they are tight properly. Okay, now the other source of error might be, okay, potential drop of the dry cells, or say voltage drop of dry cells. Precautions, okay, you say unplug or switch off, switching off the switch or key, switching off the switch or key after every readings, if you have collected the readings, make sure that you switch off the key after every readings. Okay, that marks the end of today's experiment. Thank you for your attention.